Hello everyone. So thank you for watching this lecture video. So this is a summary and formula for topics for this exam P1. So we have those kind of those kind of problems. So we just have a basic review for total topics. First one is the final probability. So the basic idea for final probability is just the separation or partition. We separate all into parts. So then we have those kind of problem. Like we pick 5 students. So what is the probability? We get 3 male and 4 female. So the problem just from this part pick some, and from this part pick some, right? So let's check this example. Like we have 12 generate. So 12 generate. So among these 12 generators, we have M generators have those, and so we just split into 2 parts. Like we have totally 12. So among the 12, we have M. Those have electronic shock, and then other one 12 minus M. We just split into 2 parts, right? Okay, so we just pick 4 randomly. So from here pick 4. So totally with 12. From 12 pick 4. So then we among the 4 we have 2 generate. Okay. So we find this. So the conditions of this M we don't know. So we want to find M, right? So we just use the conditions. The probability that have 2 generate. So have 2 generate means from M we pick 2. Then from others, from 12 minus M pick 2. So this we have 2. Yeah. So this equal 12 times 12 multiply that they have 3 generate. So this equal like a 3. So we forget the denominator. So 3 is M pick 3, and then 12 minus M pick 1, right? Yeah. So this so we have this, right? So this M pick 2, and 12 minus M pick 2. This probability equal 12 times this, right? So from here we can find this M. So for 2 factors, so typical simple example is like we split all students into 2 parts, male, female. We will split by 2 factors, male, female. We can split by male, female, and also we can split by their grades A, B, C, D, right? Yeah. So we can have those those probability or those conditional probability. Like so for PA, so probability for getting A. So here we just check from all students. So we just check for all students totally 50. So among the 50, how many got the grade A? So we say 7. So here we don't care male, female, right? So those are the probabilities. Of conditional probability means we just focus on male students. So male students, we have totally have 20. So we just check among 20, how many students got A, right? So there's a conditional probability. Yeah. Okay. So for 2 factors, we usually can use 2 by 2 table or 2 by K table. Okay, so let's say we can check like A or not A. So we just split the factor A. So we have 2 parts, like A or not A. And if we factor this like B or not B, so we can have such a table, right? So here totally, so here suppose totally 100%. So we can find we can separate A or not A. Suppose A is 30, then not A 70, right? We also can separate B or not B. So suppose B is 40 or not B is 60. So to fill out this table, so we need some other information, right? So this cell is A and B. So this is B but not A, right? So we also can use the Venn diagram. Okay, so once we Venn diagram is just like this table quite the same. So this is so suppose this is A, right? So this is B. So this part is A and B, and this part is A, B. So this part is A but not B, right? A B bar, right? So this part is B A bar or A bar B, right? So outside is A bar B bar. Okay. So we just separate whole thing into 4 parts. Just like here, we separate into 4 parts. Okay. So we can have those kind of problem, right? So like for example, so we can also find conditional probabilities or just a conditional probability, just focus on those parts. We also can consider those conditional probability. The total is A or B. So among A or B, what is the percentage for A? Like this, right? Okay. So let's say like here, we can put those information on this table. So once we have the table, we can find everything, right? So let's say PA and B equal 0.2, so there's a 0.2, and PA equal 0.4, so PA equal 0.4, so we know there's a 0.2 also, right? And A or B is 0.7, so A or B is 0.7, so this A or B is actually there's 3 cells. So this is 0.7, so we know this is 0.3, right? So this also so we can find this also 0.3. So we fill out this table, and so here 0.5, 0.5, right? Okay, so from this table, so we can find everything. So let's say find this. This is such a probability like B bar not B, B prime means not B. So among A, so total among A is 0.4, right? So among the A not B bar, among A how much for B bar? B bar 0.2, right? Yep. Okay. So here we have many of those kinds of problems. We just split it all into parts. So there's a part, there's a part. So like for this problem, we have like 22% with the both. So this fact and this fact, and 12 with none of them. So we just there's 2 facts. Okay. So if we for 3 facts, so we just use this Venn diagram. So each fact, so we have 3 like A, B, C. So for those kind of problem, we usually put this first. So right. So then this part means like A and B, but not C, right? So we can put those information. So put the information into this Venn diagram. Okay. Okay. So we also can find the conditional probability. So like the condition among those B and C, among those B and C. So what is B and C? B and C, this part, right? So suppose that this part is B and C. So among B and C, how much for A? So A is this part, right? So the probability is this part over all. Okay. So such a problem, like we have 3 insurance plans. Yeah. So we just use one diagram to put those informations to this Venn diagram, so we can do the problem. Okay. Okay. So for many factors, we can just check also check this part. So we have, if we have more than 2 factors, we have a conditional probability. So let's check this, right? So what is this probability? So meaning is like we just check those larger than 60. We just check those people, and then how much for like this count for how much for total. Okay. Okay. So such a problem very easy. Let's say so x for uniform from 20 to 100. So conditions just 60. Okay. Conditions is 60 and then 80. So we just check there's a probability for 60. So the people, the probability of larger than 60 is only 40, right? So among the 40, how much larger than 80? So 20. Okay. So for if once we separate all into parts, so when we find check a probability, so there's a probability for all. So we see if we separate all, like separate people, like there's 3 parts. So check no overlap here, no overlap. So we need to check like suppose like we separate all people into these 3 parts. Then we need to check this part, check this part, check this part, right? So we have this formula. So just check this condition, check this case, and under this condition, what is the probability? So this probability, this formula we call whole probability, or 4 probability formula, right? Okay. So now let's consider this example. Okay. So let's say okay, so here we just split people into parts, right? So like we just say 70 those, 30 those, okay, and smoke, non-smoke. Oh, we just split into 2 parts. Yeah, okay. So for people we just split into 2 parts. So here the no smoke is those count for 70% is here and 30% here. So you pick one. So if you pick this guy, so such chance is 0.70%. If you pick this guy, then the lifetime for them follow exponential distribution, right? So and if you pick one from this, then their lifetime follow expectation with mean 70. So we want to find what is expected expectation for all people. So this expectation is equal if you pick this one 70%. If you pick this, then if we pick up the people from this, saying their expectation is 75, right? Plus, and if you pick people from them, and then their expectation 70. So expectation for all, again, like just check this part, check this part, and check that part, right? Okay, so discrete distribution, very easy. We put all probability together, so we find values. Those problems very easy, right? So here the x we don't know, so here we want to find x that minimizes. So we need to find this values as a function for x, then find the minimum, right? So for two variables, so we have those notation. Yeah, two variables, we have conditional values, right? We have conditional values, conditional expectation, and conditional probability. Okay. Okay. So for typical discrete distribution, usually Bernoulli distribution, so 1-0 distribution. Yeah, 1-0 distribution. And the probability PQ. So for 1-0 distribution, we have this like mean expectation, mean is P, and variance is PQ. So for binomial distribution, we can say like x follow binomial distribution. So n parameters try n time, each time success P, right? So this x means like among n tries, how many times can be success. So for this binomial distribution expectation, so binomial distribution we can regard n time Bernoulli distribution. So this means np, and variance is npq. So Poisson distribution, Poisson distribution, so Poisson distribution is mean is there's parameter lambda, and variance also lambda same, and so there's Poisson distribution is usually modeled for those situations like how many things, how many those something can happen during a fixed time. So a typical example is among 1 month, how many car accidents can happen, right? Or among 1 week, how many, right? So this distribution of the probability lambda k factorial, and negative lambda, right? So for geometry distributions, try until first time for something happen. So this x, try k times, so means first one fail, second one fail, then last one, this thing happen. So this equal to p q k minus 1. Okay. So the average expectation for x is 1 over p, and variance, variance is q over p square. So negative binomial distribution means try, so you just remember, try n time at least r success. We say r success. Okay, so the formula is like last one success. So among here, the So you try k time. So here among the k minus 1 time you have r minus 1 success happen. Okay, so the formula is need k success, so equal, we just check from k minus 1 pick r minus 1, so this happen is p happen r minus 1 time, and then last one is also p, then q happen remaining times, so k minus r, right? So you should know there's a scenario for those distribution, right? We explain this, yeah. Oh, I put it to here, yeah. So and the mean values for those, so you should remember, yeah. So like a binomial distribution, and a Poisson distribution. So for Poisson, Poisson plus Poisson is again is a Poisson, okay. So for geometry distribution, oh, I made a mistake. So this is variance is not q over p square, 1 over p square. Okay, so negative, so binomial distribution is this. Okay. Okay. So for two variable discrete distributions are always easy, right? So those are easy, and so then for continuous distribution, so one variable continuous distribution, two variable continuous distribution. So for continuous distribution, we focus on those density function. Yeah. So once we have a density function, so we can have everything. So if there's a continuous distribution, then cumulative function and density function, we have this relationship. So if f(x) is not continuous, is piecewise defined, then you cannot use derivative. Okay. Okay. So let's say like so, so such a problem like we from cumulative function to density function. So let's say from f(x) to density function. So if this is continuous, then find derivative. If not continuous, so you should be careful. So not continuous. If continuous part, use derivative. The story just like that, right? So let's say for this example, so here the density function is 0, yeah. So from 0 to 5, so this part is continuous, so we can use a derivative. So this is just like a 2x over 25, right? Okay, so then at this point x equals 5. So let's say at this when x equals 5, this is okay. For this problem is no jump here, so here is 0. Yeah. So we can find the density function is this. Density function is just this, like 2x over 25. So x between 5 and 0. Okay. So if I have jump, then the jump is the probability. Okay. So for variable transformation, so the idea is that we for this density function we replace x by y, and then you should multiply dx over dy. Okay. So for such a problem, actually easy. Like we suppose x as the density function, then y. So just change this x in terms of y. So here let's say like x equal y over 1 1000 x equals this, right? So what x equal ln log this, right? So let's put as x in terms of y. So here y variable with variable, and variable after variable, those things for find, let's say for this like x follow uniform distribution, so no parameter. Okay. So variable. Okay. So here the continuous distribution. So find those things. Okay. Like suppose like this one, yeah. So x follow uniform distribution, but this two ending point also can change, right? Also can change, like maximum this one fixed, but this one can change. Suppose this is theta, so theta can change. So this such a problem become like we say variance variable after variable. So find zx or vx, we need to fix this first. So we have this like find zx. So zx, so we say ex equal, we call this a double e, like fix this theta. If theta fixed, then this expectations theta the point, right? Theta, the middle point, theta plus 50 over 2, right? So then this expectation, yeah. So for variance, we have this formula here. So variance, so we can say VEV plus VE, okay? So just remember there's a EV plus VE, okay? So we can have those kind of problem, okay? So for typical continuous distribution, actually we have two. First one, uniform distribution. So for uniform distribution from A to B, so mean is midpoint, right? And variance equals us. So we just use this formula. And exponential distribution, the density function thus, and we have this expectation of variance. So and here we also this formula is also useful, like let's say expectation. So here 0 to infinity, actually expectation x, lambda is negative lambda x dx. So this equal 1 over so this yeah, okay. And so for this variance, so maybe we can have this like x squared. So this equal we also can use this formula, okay? So variance equal 1 over x 1 over lambda square, right? So x squared is this. So for this integration, we can regard those as a formula. So for those exponential integration, for those one, like we x is negative 3x dx, like we don't need to use this integration by parts. We just try to use those formula, okay? Or if there's x squared, like those integration, if we use integration by parts, this is just too complicated. So we try to use this formula. Okay, so here also use this formula like x larger than a is this. So between A and B is this. So x larger than a is just negative lambda a. X less than a is just 1 minus negative lambda a. So we can use this as a formula. Okay, so such a problem very easy, right? Yeah. So like if x follow exponential distribution, from this we can find this. So normal distribution. So normal distribution, we just changing this normal, general normal to standard normal. Then we need to check the normal table, find some probability. So normal plus normal is this. Normal plus normal still normal, and mean is this. And so variance add them up. So and coefficient square. So we have this. So normal plus normal, normal minus normal, still follow normal. Okay. Okay. So now let's suppose we have such a problem. X follow some normal distribution, Y follow some normal distribution. Then we find those probability. X plus Y is less than A. So x plus y, this is also normal distribution, right? So for normal distribution, we have also percentile. So percentile is just such a cutoff point. Okay. So like let's say if there's 80%, 81%, so this cutoff point is 81%, 81 percentile. Okay. So centrally limit theorem is if we do something many times, so the total will follow normal. Okay. So just like if we play a game many times, the total will follow normal. If we have many people, then their total will follow normal, right? So let's say like if we have like 69 people, and their total premium, so the total result will follow normal. Okay. So we also need to sometimes modify the variables. For a typical example, the insurance policy, right? We have X as loss and Y as payment. So insurance company will not pay the loss, exactly pay loss. They will need to have deductible, or they have some co-pay, like you need to pay some. So their company, insurance company will pay some, right? So and they have like co-pays, not co-pays, maybe not just co-pay. So here we have those noted deductible or limit and co-pay. So limit is above that, they at most pays us, right? Yeah. So those are typical examples. This is those are typical examples like a loss follow exponential distribution. Deductible is 50, then find expectation of payment. So for two variable continuous distribution, we so some is very some is very easy. Like let's say like here, so if they are independent thing, so join the distribution is just x from 0 to 3, y equal to 0 to 5. So we can say this as uniform between this region. So what is this probability? So x larger than y, so x equal y, x larger than y. So just need to find this part count for how much for total, right? Okay. Yeah. And so for cumulative function, just for two-way two-variable cumulative to one-way cumulative, we just let the other one is the largest one, right? And so this from the density function cumulative to density function. So if continuous, we can use derivatives, partial derivative, but usually if this is not continuous, we cannot use this. Okay, so from cumulative function to this, so maybe we should go to density function first. Density function, then go to this. Okay. So find the cumulative function for some new variable. So such a problem, like find the density function for this new variable, we need to find the cumulative function first. So cumulative function, there's a probability like z less than, let's say z. And so here, what is z? So this is x, y. So we just need to find this probability x, y, x plus y less than z. So find this probability. Then regard this as a continuous. This is a continuous function for z. Then use derivative, right? So find the density function. Always like use this way almost. Find the cumulative function first. Okay, so here the same, like if I is to find the cumulative function, so x, y are independent and both of them follow exponential distribution. So find this. So conditional probability, let's say conditional density function. Actually, we can regard this like if y fixed, then this just this density function, we just let y fixed, y equal y0, like just like a fixed y. But this, so let x change, y fixed. But this maybe is not a density function because the total probability not equal 0, so we just multiply the constant k. So this constant is just this. This y0, so constant is just the total probability for those x, right? So just like this. So total probability for x. So this one actually is just the marginal density function for this y. Okay, so the idea is quite the same. So here we also have conditional. So conditional just focus on idea just like that. Fix this, then make this as a density function. Okay. So for such a problem, like we want to find this. So we just fix x equal 2. So what is the density function for y? Like here, find the values. The same idea of when fix x, find the density function for y. Then once we have this, we can find the values or expectation, right? So the condition can add condition under this condition, find expectation of y. So we just find this under this condition, what is the distribution for this? Okay. So there's covariance and correlation. Covariance is the definition of this. Correlation is divided by their standard deviation. So we say we just make correlations between -1 to +1. Okay. So this is the formula sometimes used for like if we have two variables, then the linear combination of x and y we regard it as new variable. So find this new variable's expectation of values. This is the formula. Okay, so such a problem is actually easy. So variable transformation, if this for one variable, easy. So two variable, so such a problem is tough. Such a problem is tough. So usually we just like this. If we have this t, so we want to find the density function for t, or we let it define z, so find the density function for z. So such a problem, we just find the density function first, and then we can find the variance or expectation or probability. We can find everything. Okay. So so we have moment generating function. So moment generating function definition is this, and moment generating function. So from moment generating function we can find all moment. So we have this, right? So first derivative, the first moment mu1. So mu2 is just second derivative, and the moment. So if x plus y is moment, general function is just a multiply. Okay. So for such a problem, if moment general function is just like that, then we can easily find its distribution for x. X can be like a -2, and x can be 0, and x can be 1, right? So according to definition, so probability here is 0.2, so 0.5, 0.3. So from moment general function, we can have its density function or distribution. Okay, so joint moment general function is this. So MST is those expectation of Sx plus Ty. Okay, this is definition. So from here find variance of y. So this means find mu2 minus mu1 squared. So we want to find moment generating function for y. So let's say from this moment generating function, so we can find moment generating function for x or for y only. So for y only, we just let this x equals 0, right? Let x equals 0. So this one, this is just the moment generation function for y. Okay. So then by now this problem very easy, right? So there's a probability general function. I haven't met this. So if we have many variables, we can find a maximum or minimum. Maximum, minimum. So we can find a maximum, minimum's density function or cumulative function. So here for y, let's say we can find this, let's say cumulative function, right, for y. So this is probability for that those maximum less than y. So maximum less than y, so means each one should be less than y. So this equal each one less than y is just the xi. So xi is x, xi is y. Okay, yeah. Okay. So for minimum, we find the density function or find cumulative function. For minimum, we just find if minimum larger than a, then each one should be larger than a, like that. Okay. So if we have many variables, so we have this formula, and so here typical situation we have centrally limited theorem. Okay. So, and then finally we have some math formula. So for integration, just the results like a power function or exponential, right? And for those, we can use use integration by parts, but usually we just remember this, like for x follow exponential distribution, then x equal 1 over lambda. So this x equal lambda, what this means is we can regard this as a formula. X lambda is negative lambda x dx. This one is 1 over lambda. Okay. Okay. So for integration, the most important is substitution. Make things simple. Right? So for example, if we have this integration from 1 to 5, so x minus 1 squared dx. So we do not expand this. We just let x minus 1 equal t, right? So this become a t. So this become t squared dt, and t from 0 to 4, right? So use this, make things simple. Okay. So those are almost all the topics for this exam. Okay. And for derivative, sometimes we need this derivative, yeah. And for some summation formula, typically this, yeah, geometry. Okay. Okay. So we can stop here, and those are all topics. So I hope you can just go over those materials and just check those exam sample problems. Then you can easily to pass this exam.